Alright, right now we're going to look at how to balance redox equations and use a couple examples from the homework for the balancing of redox equations. The first one we're going to look at is 63A, and this is taking place in an acidic solution, and this is the information that's given to us for this acidic solution. So the first thing we need to do is first of all determine the oxidation states of each of the elements and compounds. So we've got elemental zinc with an oxidation state of 0, and hydrogen with an oxidation state of 0. Then we've got HCl. HCl is +1 and -1, and zinc is +2 for its oxidation state. From this we can see here that the zinc is going from a 0 to a +2, so it's losing electrons, and the hydrogen is going from a +1 to a 0, so it's gaining electrons. So when it loses electrons, that's oxidation. Zinc is being oxidized, Zn going to Zn2+. The hydrogen is being reduced, HCl is going to be reduced to H2 in this reaction. So the next thing we check after writing the balanced half reaction is to balance everything but the H's. So in this case the Cl's are not balanced, so we can add a Cl to this side. Then you can balance all but the balance the oxygen, no oxygen. So now we go to balance the hydrogens out here. In order for this to work, we would need 2 there and 2 there for the Cl. Now for this reduction equation, some people would write this here as you have 2H plus going to H2. That would be okay as well without the chloride ions, because HCl is one of the strong 6. As a strong acid, it would be shown as 2 separate ions in solution. So this one, the bottom one, would be okay, and so chloride ions would not be in your reactants or your products of your final answer. Now once you get past that point, the next thing you need to do is to balance the electrons. So in this one we've got a 2 positive, so we need to add 2 electrons to this side here. Here we've got a 2 negative, so you would need 2 electrons here on this side here to balance it out in the reduction. Okay. They equal out, so then we add these two together, the oxidation and the reduction equation, add them together. The 2 electrons cancel from both sides. We're left with Zn plus 2 HCl produces Zn2 plus H2 plus 2Cl minus. And this here, since it's an acidic solution, would be our final answer for problem 63A. Again, assuming that the chlorine is necessary in the solution, even though it doesn't change oxidation state. Here's problem 63C that happens in acidic solution. In this case here, we're looking at assigning oxidation numbers first. So the first things we want to do is find the oxidation numbers for all of the compounds and ions. So we got oxygen is usually a -2. 3 times 2 is -6 here for this one. So that means that this has to be a +6. So a +3 for the arsenic and As2O3. And we look at the nitrate, -2 times 3, -6. This is going to equal -1 total with the -1 charge here. So the nitrogen has to be a +5 minus 6 to give us the correct oxidation state on nitrogen. Here in ASO4, get 2, -8. Hydrogen is +1, there's 3. So arsenic here with 0 net charge on the molecule has to be a positive 5 for its oxidation state. In NO, net charge on the molecule here is 0. This is negative 2, so nitrogen has to be positive 2 here. Well, the oxygens here are always negative 2, so they are not being oxidized or reduced in this example. But the arsenic here, we look, it goes from plus 3 to plus 5. So in order for it to do that, it has to lose the electrons. And then we look at the nitrogen, plus 5 all the way over the plus 2. So it has to gain electrons in this process. So the arsenic's losing, the nitrogen is gaining. So when you lose electrons, that's oxidation. And when you gain electrons, that is reduction. So the arsenic is being oxidized. The As2O3 going to H3ASO4. And then the substance being reduced is our NO3, 1 minus, going to NO. So once we have our half reactions written out, the next step is to balance everything but the O's and H's. So our arsenic, we would need to put a 2 here to balance out the H3ASO4. We've got 2 arsenics, 1 nitrogen, 1 nitrogen. Now we go to balance the oxygens. It's 3 oxygens on this side, 1 on this side, so we would need 2 waters on the right side. We look up here, we've got 3 oxygens on this side, 8 oxygens on this side. So we've got 3, and here we've got 8. So we need a total of 5 more oxygens, 5 more waters on this side being added to balance the oxygens. In step 4, we want to balance the hydrogens, so we add H pluses. Here we've got 4 of them on the bottom, so 4 H pluses added to this side. Here we've got 10 hydrogens and 6 hydrogens, so we want to add 4 hydrogens to the right side. Next step is to balance the electrons. So on this side we've got 0 charge on the oxidation reaction. This side we've got 0 plus 4 hydrogens, so we would need 4 electrons to balance the oxidation. Balance the electrons on the oxidation. In the reduction one, we've got 4 positives and 1 negative. That's 3 positives total, 0 on the other side, so we need 3 negative electrons to balance the electrons. Now we have to equalize the electrons, so we would need to multiply this oxidation reaction by 4 and multiply this, the reduction reaction by 4 and the oxidation reaction by 3 in order to get the same number of of electrons on each side. So if we change this around here, we would have 15 waters, 3 of these, 3 of those, 12 hydrogens, and 12 electrons. Then we look at this one, 4 times 3 is 12 electrons, 16 hydrogens, 4 nitrates, and then 4 NOs, and 4 times 2 is 8 waters. Next step is to add all of these up. The 12 electrons here cancel out, so let's change this to a different color here. So our full 12 electrons here cancel the 12 electrons on this side. We've got 12 hydrogens on this side and 16 on this side. So they cancel out some of these. 4 hydrogens are left here. Okay, waters, we got 15 waters on that side and 8 waters on that side, leaving us with 7 waters here, and that cancels out here. The next step is to put them all together. So we've got 7H2O plus 3AS2O3 plus 4 hydrogen ions plus 4 of the nitrates. that produces 3H3ASO4 plus 4NO. And that should be our answer, number 63C. Looking at number 63, looks like this is incorrectly multiplied. It should be 3 times 2. That should be a 6 here for that one. So that changes this too. Should be a 6 here. And this here should be our final answer. For the balanced redox reaction for 63C in acidic solution.